The image presented in most science fiction films of an asteroid belt is one of huge solid rocks all moving around very close to each other, presenting a large risk for any spacecraft entering the area. However, the truth is just a little less dramatic. The most obvious thing to state is that the idea of large objects randomly moving around close to each other for an extended period of time is just impossible. The objects would collide and either aggregate into a far larger body or get reduced to a fine dust by such collisions. However, the main problem with this view is that the asteroid field just isn't that dense. It covers an enormous area. Were you to gather up all the matter in the entire asteroid belt, it would only amount to about 4% of that of the mass of the Moon. It still amounts to many trillions of tons of matter, where evenly scattered through the belt still might cause some problems, but instead most of it's actually contained in the larger asteroids. These asteroids basically fail to become large enough to form planets. Largest of these is Ceres, which has little less than 1,000 kilometers across from side to side. Because small asteroids are actually very difficult to spot, it's difficult to know for sure how many of them are there. We can, however, estimate there will likely be less than 10 million asteroids in the asteroid belt which have a diameter of 100 meters or more. Earlier on in the solar system's history, there were far more asteroids in the belt, but the gravitational effects from Jupiter and the other planets combined with collisions within the belt itself forced much of the mass within the asteroid belt out, resulting in the asteroids bombarding either the other planets or falling into the Sun. Now, for the most part, the asteroids orbit the Sun at the same speed as other nearby asteroids and keep relatively far apart from each other. However, like vehicles going around a massive motorway, there are still occasional collisions. Especially, some of the asteroids pair up and orbit each other in a similar way to Pluto and Charon. This doesn't mean the distribution of asteroids across the area they occupy is perfectly even. Far from it. In fact, if you look above, the asteroid belt would appear to be a series of rings, resembling in a slight way those round Saturn. This is down to something called the Kirkwood gap. Basically, as an object orbits the Sun, the further it is out from the Sun, the longer it takes to complete an orbit. It's partially because they have a longer distance to actually cover to complete a complete orbit. Also, that the further you go out, the planets and other bodies are actually travelling significantly slower with the reduction in the gravitational force being applied by the Sun. So, for example, Mars actually has an orbital velocity which is about half that of Mercury. This means that occasionally various objects in the solar system have orbits which align with each other, and their gravitational fields can affect each other. Of course, the larger an object's mass, the greater the effect, with Jupiter being the largest planet having the greatest effect. And most often these alignments happen at different parts of the orbit of the bodies. However, sometimes these alignments happen at the same part of the orbit, and the gravitational kick from Jupiter is like pushing on a swing. And this push can push an asteroid out of the belt. And this is where we have the Kirkwood gap, or more properly, the Kirkwood gaps. Since the asteroids are orbiting inside the orbit of Jupiter, they complete their orbits quicker. However, when their orbits match up, for example, they complete 3 orbits for every 1 of Jupiter, or 5 orbits for every 2 that Jupiter completes, then they experience this resonating push from Jupiter, resulting in orbital gaps or bands in the asteroid field that are virtually free from asteroids. They're also less dense in and around these zones. That leaves us with what these asteroids are actually made from, which I'll cover in the next video.